If the angle of rotation or the angle measurement is between pi and a 3 pi over 2 radian, which on the current plane is going to be third quadrant, and the sine data times cosine data is equal to 1 over 4, and sine squared data plus cosine squared data is equal to 1 according to the given conditions. The first question is, what is sine data plus cosine data? So we already know that this is a basic setup for a unit circle from the previous videos. So when the angle is 0 degrees, we note it as 0, and when it rotates 90 degrees, and when it gets to this point, then we call it as pi over 2 radians. When it rotates from the 0 radian to all the way to pi radian, which is 180 degrees, and then when the angle rotates 270 degrees, which is 3 pi over 2 radian, and then lastly, when it finally reaches back to 0 degrees, then it will be 2 pi radian as 360 degrees. And because the angle theta, where we always assume in the trigonometry to be the acute angle, which is greater than 0 degrees but less than 90 degrees, is between pi radian, which is 180 degrees, and 3 pi over 2 radian, which is 270 degrees. Because the angle theta is on the third quadrant, we can make prediction where the data will look something like this on the third quadrant. If you think about the trigonometric values for this point, we can figure out that in the third quadrant, the x and the y coordinate are both negative, which means using the fact we learned in a previous video, we can figure out cosine data, which is the x coordinate of the point on the unit circle, is going to be less than 0. So if you define it, the trigonometric value of this point, which with the angular rotation data, the first value we might think about is the cosine data, which is going to be the x coordinate of that point according to the fact we learned in the previous videos. And because the cosine data is the x coordinate of the point on the third quadrant, that will be less than 0, which is negative. And the next value we have to think about is the y coordinate, which is going to be the sine data. In the third quadrant, the y value is less than 0, or the negative value. So that's why the sine data is going to be less than 0. And the last thing is the tangent data, which is the slope in trigonometry, and sine data over cosine of theta. So the tangent data, which is sine over cosine data, where sine and cosine are both negative, will be the positive value. So these are the three trigonometric values we can define for that point with the angle rotation data. And if you go back to our equation, which is sine data plus the cosine of theta, we can't directly find this value because there's not much clue that we can use. However, using the fact that the square term with the sine and cosine is given, we can create the square term and input those values. To make the sine and the cosine data square term, all you have to do is think about the equation sine data plus cosine data squared. And this square value will make up the sine squared data and the cosine squared data. And all you have to do is extend this equation just like the usual quadratic equations. And if you extend it, you will get sine squared data plus 2 cosine data sine data plus cosine squared data. But if you look at this carefully, there is sine squared data and a cosine squared data. So you can combine them together as sine squared data plus cosine squared data plus 2 sine data and cosine data, which is essentially the same thing or expression we saw above. So using the Pythagorean data of trigonometry or given information where sine squared data plus cosine data is equal to positive 1, that will be positive 1, and also using the first given condition where sine data times cosine data is equal to 1 over 4, you can easily substitute sine data times cosine data as positive 1 over 4. And since there is 2 times sine data times cosine data, which is 2 times 1 over 4, that will give you the value as positive 1 plus 1 over 2, where 1 can be notated as 2 over 2 as a fraction for the common denominator to add them easily. And that will give you the value as positive 3 over 2. And 3 over 2 is going to be the value for sine of data plus cosine of data squared. And then the value we're trying to find is sine data plus cosine data, not sine data plus cosine data squared. So to find the value, we have to undo the square by taking the square root to the both sides. So when you take the square root to the both sides, you will get sine of theta plus cosine of theta is equal to plus or minus square root of 3 over 2. And we have to be careful with that plus and minus sign, because even if it was plus or minus, if you square this square root of 3 over 2, you will get the value of sine of theta plus cosine of theta squared. So you always have to not forget the plus or minus sign. And then we have to find one of these values, which if it's going to be positive square root 3 over 2 or minus square root 3 over 2. But one thing that defines is that we already know that the cosine of theta is negative and sine of theta is also negative. When you add those two values that are both negative, you will always get the value that is less than 0. So that's why the positive, so there's a positive square root of 3 over 2, and there can be negative square root of 3 over 2. And for the sine of theta plus cosine of theta, the positive value won't work because it's in the third quadrant for the angle, so cosine of theta and sine theta must be both negative. So negative square root of 3 over 2 will be the right answer. And this was the question asking what is the sine of theta plus cosine of theta. And in the next video, we're using the same condition that is given, where we're going to solve another questions.